all will be covered as part of this vlog. It will have two parts. Part 1, which I named as MCU, which is microcontroller units. Part 2 is firmware analysis. In part 1, I'll be talking about the Arduino board, what microcontroller it uses, how is it useful in IoT, and then I'll show a short demo on it. In part 2, I'll be talking about what is firmware and what is firmware analysis. How do we analyze? Then we'll see a short demo using a tool named as binwalk, which will be followed by some key observations and our analysis, and we'll end this vlog by mentioning some of the security and its best practices. So let's get quickly started with it. Part 1, about Arduino UNO. Before I show any demo or mention anything, I would like to get you familiarized with what is Arduino. Arduino is basically a low-cost, flexible, easy-to-use, programmable, open-source microcontroller board that can be integrated into a variety of electronic projects. As you can see on the screen at right-hand side, there is a board which is shown. It uses a microcontroller. As we can see, this black chip, this is called as microcontroller, named as Atmega 328 MCU, which is microcontroller unit. Other than this board contains various things like ground pin, input output pin for digital and analog outputs, inputs, reset, USB interface, voltage regulators, transmitter receiver, and lots of things. Basically, it's a general purpose device which can be used into variety of projects, as already mentioned. We'll see a demo on this shortly, and then we'll get more feel about it. Firstly, I'll see how is it useful in IoT. Before that, if we see at left-hand side section of the table, we see in IoT what we need in a device. We actually need a device that can collect data from sensors, that can control motors or actuators, that can receive or send data from internet. And if we see what Arduino can do for us, Arduino can do all the things for us. It can connect to temperature, light, infrared, etc., and many other sensors. It can connect and control DC motor, vibration motors, and all actuators. It can receive data from cloud. It can send data to cloud, can interact with smart devices as Alexa, Google Home, can store results in database. And also it can be controlled by smart devices like our mobile phone, tablets, etc. Now, before I show the demo, I'll tell the problem statement which we are trying to solve. So problem statement says that we need to design a circuit using Arduino board that can read the temperature from temperature sensor and which can show us some indication in form of LEDs. That is, we'll have 3 LEDs as mentioned below: blue, yellow, and red. So if the temperature is less than 50 degrees Celsius, we'll mark it as cold and only blue light should be on. If the temperature is more than 100 degrees Celsius, which is hot, the third one, a red light should be on and it should run a motor. And if a temperature is moderate, which is between 50 to 100 mentioned in second line, it should turn on only yellow LED. So this thing we'll be designing with Arduino board. Before I show you the demo, I'll tell you about the demo. So here we'll be using an online simulator, which is tinkercad.com, since we don't have any hardware present with me right now. So all the hardware things I can show it in an online simulator. Then design circuit will have all the required components, which I'll be showing. Then I'll be using C++ code to do all this programming and to solve this problem statement, which will be burnt into that particular microcontroller, and our aim will be achieved. Last but not the least, I'll be showing the execution of it. So I'll move on to the tinkercad.com. So this is the circuit which is designed. This is the Arduino board. This is a temperature sensor. We have 3 LEDs attached to the resistors, and the particular pin numbers of Arduino board, that is 13, 12, and 7 I have taken per se. I can take some other pin of my choice. I've also attached the DC motor with the red LED pins, so that once the temperature is hot, red LED burns and or is on, then my motor should also run. I can see all the components which are used here, as it mentioned here in form of table. Coming back to my circuit. So in this simulator, I can write the code, I can start the simulation, export, share, I have many things. So firstly, I'll show you the code. This is a C++ code written. So here we have set, firstly, we are doing the initial setup, which is we are setting up the 13, 12, and 7 pin as our output pins for hot, moderate, and cold indications. Then we are running an infinite loop, defining our temperature limits, which is hot is 100, cold is 50, and in between of this will be a moderate one, as already discussed. Then we are reading out the voltage, which will come out from the temperature sensor. We'll convert that voltage into the digital values, which is called as ADC, analog to digital conversion. Once we are done with that, we'll convert our temperature into Celsius. This part shows that the mathematics. Once it is done, we'll check whether our temperature is cold, hot, or moderate. Based on that, we'll send our outputs to the particular pin numbers, which is high or low. Like for example, if I say temperature is cold, my pin number 7 should be high and 13 and 12 should be low, because pin number 7 corresponds to blue light. Similarly, for hot and low, I'll be doing. This serial monitor shows the output or the console output for whatever print statements I'm writing. This can be used for debugging as well as to visualize whatever is happening. So let's just quickly look at the code. Now I start the simulation and let's see how simulation looks. So see, if I see the output, it is showing me what is the value it is reading and the temperature values. So if I see on the screen, my blue light is on. Why? Because my temperature is around 25 degrees Celsius. So now I put the temperature between 50 and 100, which is 71, let's say. So we'll observe that blue light is gone and yellow light is on. Now, similarly, if I increase the temperature more than 100, so it is moving a bit slow actually. So see, now my red light is on, other lights are off, and my motor starts running. If you observe, now I reduce the temperature, the corresponding LED should be on, which is blue in this case, and our motor is off. So yeah, this is a very short demo, which shows how can we use the Arduino board or for other purposes. So we can solve many problem statements like this. As already mentioned, there are lots of applications, and we can have transmitter, receivers, Wi-Fi's. We can send our data to internet and lots of things. So coming back to my presentation. So yeah, this was about the Arduino board analysis. So now I come to part 2 of this vlog, which is firmware and analysis. So what a firmware is? As mentioned on the screen, firmware is a software programmed into a read-only memory. So this is a kind of a program which runs even before the operating system comes into picture. Any device, even if a mobile phone, laptops, PCs, whatever, if I switch them on, I have a piece of code which should be running, that should run some initial statements, which will trigger the OS or the operating system that should run, which will have lots of features, which will give me a user interface and many things. So what is analysis basically? Analysis is a generic term. Analysis is trying to gather the information on whatever thing we are doing the analysis on. So as part of my demo, what I'll be doing is I'll get the firmware from the internet for one of the routers, or what we can do is we can have a physical access to a router, then have some means to extract the firmware from it, then analyze that firmware. We'll try to unzip it, extract it, and we'll see what all secret information that I can take out and use it for malicious purpose, which actually hackers do. So in demo, I'll be taking the firmware of TP-Link router, which is TLWR845N version 4 201214. I provided a downloaded link from where I have downloaded this particular firmware for the TP-Link router. Then I'll be analyzing that firmware using binwalk tool. Binwalk tool is basically the open source tool which is already present in Kali Linux, or if not, we can get it easily from GitHub or internet. Then using that, I'll try to break into the TP-Link firmware. I'll see whatever information I can gather. So as part of this demo, below things are in my scope. So I'll be gathering following details: the OS it uses, the encryption information. I'll try to extract the OS and try to steal the maximum information from that extracted things. So let's get started. So this is my Kali Linux. So here I will firstly show the bin file. Yeah. So I have downloaded the firmware bin file from the link that I just showed in my slide. So let's open the terminal here and see what we can do using binwalk. So firstly, I'll run binwalk on this bin file. Nothing, I'll just write binwalk and bin file. Let's see what it gives to me. So binwalk is very intelligent tool actually. It will, as shown on the screen, it is giving me the decimal values from which particular position or whatever, what do I say, bin a particular index value of that file, what all information it is able to gather. So it is saying LZMA compressed data. Then it says squash fs file system. Oh, okay. So see, right from the starting, I'm able to get this. Okay, it is some compressed data. Then I am having squash file system embedded into it. So it is embedded in the last part of this particular file. So I have a command binwalk -e and file name. If I run this, it will show me the entropy graph. It uses the Python code internally. And if we see, this entropy seems to be too high, which is 1. So yeah, firstly, I should tell what entropy actually is. Entropy is actually the measure of randomness. So if a file is encrypted, of course, it will have random values inside it, just to misguide the user or malicious user or whatever. So yeah, from here we can conclude most of the time the entropy is 1 means that many places, many of the offsets, we have lot of random data. So this surely says the file is compressed. Coming back to the demo. So now I will try to extract this. Let's see what it does. And I press the enter. So it is trying to extract the bin file, and let's see what it can extract for me. So it is saying compressed data. It is able to find squash file. Okay, fine. And it is giving me some warning. That's okay. ls-ltr. Okay. So yeah, it has extracted something for me. So yeah, these are the previously extracted files, and this is the new file which is extracted. I'll open this one. Okay. Okay, so as you've already seen that it is a squash fs root system. Squash fs root system is basically the Unix like file system. So once I enter into this, let's enter to the root and see. So this is, I don't have the router available with me, but I've got this from the from the internet, this router, and I'm trying to analyze. So how dangerous it could be, I'll just show it to you. So I'll do ls, and generally I know in the Unix file system in etc and in users we have some details. Let's go to etc. Let's go to etc folder. So by now you might have guessed why I'm going to etc, because I am trying to steal some passwords, right where the passwords are stored. Generally, okay, let's see if there is any shadow file. No, shadow file is not present. That could be a problem. No, I can see this file, password.back. Let's see what I can see here. Oh, great. So here for admin, it is showing me some values. For drop beer, it is showing me X. X means it is an encrypted one. And for that, I need to do some more analysis, find the shadow file, run some John the Ripper tool or any other tool to match the hash and extract the password. But yeah, here I can see something, right? I can see, okay, this is not even encrypted one. So yeah, it could be a password as well. Fine, yeah. So this was about the demo for binwalk, and we can use many other options with binwalk. I can even go to help section and it will show me what all can be done with it. So yeah, this tool is very vast and a very good one, which can almost be used to hack something which we can think of. Okay, coming back to the PPT, we have already seen this entropy one. So observation and analysis. So first point says entropy is high, which means the file is encrypted, of course. This is FS is Squash. Squash FS is a compressed read-only file system for Linux. There is no shadow file. It could be hidden or somewhere. We have to analyze more and find it. The passwords were present in password.bak file. The password for admin is not encrypted as there is no X in the starting. So yeah, we need to have some Linux knowledge, and yeah, for Squash FS, most of us have Linux knowledge, and okay, we use that, get the information. Person will not even know, okay, what have we done? And we know this is just the starting point. Once we have passwords for anything, the system will be compromised. So to end this vlog, I'll mention some of the best practices. IoT device must be prevented physically. What it means, like just now I showed that we have this firmware present with us, and I was able to analyze, and almost I reached to the password stage. I almost got the admin password, right? So if the device is physically prevented, then at least someone will not be able to take out the firmware from my particular IoT device or whatever device. And there are lots of chances or high chances that my system won't be compromised. Even if user has physical access, we should use the software security. Must use encryption. Should not allow anyone without a key to change or read the firmware. Always use firmware from the trusted sources, and do not use default passwords. With this, I would like to end my vlog. Thank you for the patience listening.